Hey, welcome back to another online lesson. This is lesson 1.4 and we're talking ratio tables. Words to know. Really the biggest piece of advice for ratio tables is that when you think equivalent ratios, think equivalent fractions. Now, equivalent fractions are something you've probably been dealing with for years. And what I mean by that is, say you have 1/2. Well, an equivalent fraction to 1/2 would be 2/4. And how'd you get there? Well, if you times by 2, times by 2, 2 times 1 is 2, 2 times 2 is 4. Awesome. And an equivalent fractions for 2/4 you could get by just times 10. Times 10. So that would be 20/40ths. And they all mean 1/2. When you think equivalent ratios, keep that in mind that you're just dealing with equivalent fractions. Let's put it to use. Okay, so here we have a word problem that we're going to have to find equivalent ratios for. A patient receives 1 liter of IV fluids for every 8 hours. So right away we know our two words are going to be IV fluids and time. In this case it's hours. At that rate, find how many hours it will take to receive 4 liters of IV fluids. So in this case here, the table is already set up for us. IV fluids liters, we know it's going to be 1 liter in 8 hours. And that empty box right there, that's our sort of our question mark. That's what we have to fill in. So if 1 liter for 8 hours, well, how long will it take for them to get 4 liters of fluids in? So you say to yourself, how do you go from 1 to 4? Using only multiplication or division. If you add, it doesn't work. Just like with equivalent fractions, you have to multiply or divide to get there. In this case, you have to multiply or divide to get there. So how do I go from 1 to 4? Times 4. So if you times the top by 4, what do you have to do to the bottom? Times 4. And in this case, 8 times 4, that is going to equal 32. So my answer is, at this rate, find how many hours it will take to receive 4 liters of fluids. The answer is going to be 32 hours. Cool. Makes sense? Awesome. So now let's look at another example. Cool. Okay. So here we have another example. This one is cans of corn are on sale 10 for $4. Find the cost of 15 cans. Okay, so we set up our chart already. Cans of corn versus cost in dollars. Cool. Cans of corn, we know it's going to be 10 for $4. But we want to know how much 15 costs. So the first question's got to be, how do I go from 10 to 15 using multiplication? Well, you're probably thinking right now that there is no way you can multiply 10 to get to 15. 10 times 1 is 10, 10 times 2 is 20, that's too high. So in this case we have to do something called scaling, or I refer to it as build a bridge. We need something to bridge us to get from 10 to 15. So let's think. 10 to 4. Is there a number, almost like a rock? Picture you like jumping over a river. And you can't get all the way across the river, but we got to build a rock right in the middle of the river. So we can jump on that rock to then jump to the other side. So what we're doing is we're trying to jump from 10 to 15, can't quite make it. So is there a way we can go from 10 to a number to 15? So start thinking about numbers that go with 10 and 15. Hopefully, in your brain, you're thinking 5. Okay. So can I get to 5 from 10? Of course we can. Divide by 2. Well, if you divide by 2 there, you got to divide by 2 here. 10 divided by 2 is 5. 4 divided by 2 is 2. Awesome. So now we jumped on that rock, now we got to jump to 15. How do we go from 5 to 15? Times 3. And how do we go, what do we have to do to 2? Times 3. 2 times 3 is 6. Therefore, my answer is, what's the cost in dollars for 15? The cost is going to be $6. Perfect. Let's look at one more example. Not that one. Okay. A child's height measures 105 centimeters. Estimate her height in inches. So, height in centimeters is 25, height in inches is 10. We have to get from 25 to 105. There's no way you can multiply 25 to get to exactly 105. So we have to do some scaling. Are we going to bring our number up, or are we going to bring our number down? A lot of times it's easier to bring the number down. In fact, that's what I'm going to try here. So I see 25 and 105. Right away I see that they both end in 5. So I know 5 is divisible. So I'm going to try to make my little bridge there, make my little rock a 5. So let's see. How do I go from 25 to that? I'm going to divide by 5. That gets me 5 there. And if we divide by 5 there, we got to divide by 5 here. 10 divided by 5, that's just going to be 2. Now, how do I go from 5 to 105? Well, it's going up, right? So we have to multiply. So 5 times what is equal to 105? I have no idea, so let's do the math to figure it out. That would be 2, 0, that would be 5, that would be 1, 5, subtract, boom. So therefore, the answer is times 21. And what we're going to do here is we're going to do times 21. And 21 times 2 is going to be 2, 4, is going to be 42. So the answer of the height in inches is going to be 42 inches. Awesome. I know this seems kind of foreign, but again, these notes are just made for you to sort of have a general idea of what we're going to do in class tomorrow. Be ready to work on these ratio tables, and by the end of class tomorrow, you're going to be an expert, I promise.